All right. Is everyone able to get an answer for each question? Like the time is like somehow okay, right? It's roughly like a minute, minute and a half, or no more than 2 minutes for each question. So if you recall back in college algebra, I remember on the midterm there were like 20 something questions, right? And you get like a whole hour, not necessarily a whole hour, like a 50, 55 minutes, right? So that's very reasonable. That's why, when you're doing the daily practice, so you should aim at getting some of those questions, right? If they're easy ones, get it done, like in a minute or something. All right. Now, how about we do, the same thing that we did last time when we couldn't have the cool worked out for you guys, right? I said, raise your hand, your number of fingers, tell me which option you would pick. So I can have a quick idea, how many of you are getting it right. But no pressure, if you don't get it, they just, suggest that, hey, those other questions you're gonna have to work on for the quiz, right? And, if you seriously need help, come by and, I can easily come up with questions. There are different numbers, right? To provide you some assistance, but then later on you're gonna come back and convince me you're at the level. Right. But right now, I think that if you do realize that you need some time to process or try to recall the identities, it's perfectly normal. Right. Now let's say this is A, right? B, C, and a D. Right. So now everyone raise your hand and tell me what you're gonna pick for 18. Okay, so I see, a lot of hands with, choice of the letter C, right? And that's correct, right? Now, can anyone share with us? Yeah, thank you. What identity you have to use for number 18? Either describe it, or if you happen to know the name, that would be even better. Anaya. Okay, yes. Now, inverse might be a little bit different, in different, branches of math. So back in college algebra, inverse means the inverse of a function, right? So in number theory, inverse means reciprocal, sometimes, right? Now I guess that most of you go to pre-cal, in the summer, right? Uh, we'll be getting matrices, and the inverse of matrices are sort of like inverse of a number, but it can also behave very differently. Now the actual name of the identity is called the reciprocal identity. Cosecant and a sine are related, right, through the reciprocal, right? So you know that if you already know the reciprocal, you know what the names are actually, exactly what you, are getting. Now let's try number 19, right? Again, raise your hand to let me know what you pick for number 19. Number 19. Okay, good. All right, it's letter B, right? Now, what's the name of the identity you use for getting tangent out of the sine and cosine? Or what does the identity look like? Yeah, Alex. Sine divided by cosine, right? So over cosine, yeah, it's called quotient identity, right? So you're forming a quotient using sine and cosine, you get tangent. If you flip it, you get cotangent, right? Good. Now, last one, number 20. Yeah, what do you guys pick? 20. Good. Yes, it's letter B. So I guess that, the secant and cosine, right, are reciprocal of each other. All right. So now I have 3 more questions, but now let's try to push yourself, a little bit more. I'm gonna give you 4 minutes. And again, please remember we're gonna pick, right? And I'm gonna check as a whole class. All right, go ahead. Timer for 4 minutes.
4 minutes starting now.
Thank you. So now, 3 minutes and 54 seconds. Try to limit your use of calculator. Still checking very basic identities. If you're done with 3 questions, if you happen to bring a scientific calculator, take it out and maybe play with the calculator by trying the tangent, sine, cosine at various angles. Right. Also, what I want to look into it is if you do have a physical calculator, there's typically going to be 2 modes, right? Either radians or degrees. You might have to find out how to switch back and forth, right? But every calculator is different. Again, if you're done with the 3 questions, take out your scientific calculator if you have one. Play with some random angles evaluated, right, in a sine, cosine, tangent function. But also take a look at if there's a way for you to switch to a radian mode or a degree mode, right? We're gonna use that in a few minutes. Okay, so that's about the time. All right, so let me quickly check. Now let's say 23. Raise your hand. 23. 23. Okay, so let us see. All right. Now, this is obviously checking the cofunction identity, right? But if it's not that obvious, then this is exactly what you want to learn from the test repacking. Right? So I know that it doesn't sound like a good strategy for SAT math because you can never really predict, what you might have. But for our test, I think that it's very predictable. So you should, later on, this is the first, right? And later on will be a second packet for the first test. As you go over those questions, also you want to remind yourself, okay, when I see something like that, right? See those numbers, right? What was the identity that you're checking? So cofunction, So I want you to think about the cofunction of a sine, which better be cosine, right? So now you're looking at cosine. There are two options here. It's either cosine 48, cosine 42. We know that cofunction identity is kind of interesting, right? So function and cofunction are related in such a way that when they're evaluated at angle and it's complementary, then their values are equal. That's why sine 48 would not be equal to cosine 48, but it will be equal to cosine of 42, right? Because 42, 48 add up to be 90. So it's a function and it's cofunction, but you have to evaluate the angle and it's complementary. All right, so now let's see, 24. Go ahead, raise your hand. 24. Great. See that everyone. Yeah. So it's letter C, right? But it should be obvious, right? 10 and cotangent, right? The angle 62 and 20 add up to be 90. Now the last one, 25. Go ahead. Perfect. Number 1, right? So the same logic, right? So sine and a cosine are related through the cofunction identity. Now, if you don't like the radians, at least you can take some strategy for multiple choice, right? Because those guys are not very likely to be the same each other, right? Because they are literally different. But those two are the same because if you happen to notice, pi over 5 and a 3 pi over 10 add up to be pi over 2, right? So let me put it down here. Now, if you want, do the subtraction. What is the comprehension angle of pi over 5? So you're gonna take not 90, right? But pi over 2 radians minus pi over 5. So you know that you're not really subtracting the pi, right? So just put the pi on the side. You're subtracting 1/5 from 1/2. So you have to find out the common denominator. So you know that they don't have anything in common. So the common denominator will be 2 times 5. So you get pi 10, right? Multiply 5 on the top and bottom. Here, 2/5, not 2/5, 210. Get 310 pi. So of course, sometimes I think that maybe adding up angles to verify if they do add up to be pi over 2 might be a bit easier, right? This is by half, right? Not by half, but 2/10, 3/10, right? Add up to be 5/10, right? Which is 1/2. But like I said, you should be able to figure out letter A, even without carrying out those explicit calculation. Just think about, right? When it's down to only 2 options, right? It shouldn't be too hard for you to see that which one might be the only one that's reasonable. All right. Now let me get to the last thing that we didn't do for 5.2. Oh, just in case. Just a little heads up for tomorrow. In class, we will do a XAT practice. It's not a test, but it's also very similar to the kind of diagnostic thing you did. So we'll see that if we seriously have to grade it, I doubt it. Diagnostic, since we have a meeting, when we have all the instructors, especially English and math instructors, get together to study the student data, that's what we have to seriously grade it. Now, for practice assessments in the past, I feel like that I don't even have to, print out those packets. I'll probably just share with you on E2L. You can pull it on your device and, work it out, and I'll release the answer after you try it, right? So I'll probably get you like maybe 30 minutes, right, to give it a try. Then once you're done, you can either raise your questions about like certain, things that you want me to discuss, or I'll just pick whatever question that I think that might worth discussion, right? But also tomorrow, since that will be our first official test prep, sessions in the afternoon on Fridays. There will be also something else I want to share with you, like what kind of resource you should get, and what will be your test preparation, routine or on daily basis to look like in the next couple months. Now tomorrow morning, I'll be in building 15, room 103 for tutoring. All right, it's for math in general. So it could be SAT math, or if you need help with quiz questions, you could come, and again, I'll try to still provide you some assistance, but not as much as you would expect. So room 103, building 15, 103, from 9:30 to 11:30. No need for appointment. Just walk in, and typically there should be more than one student there, because there'll be 3 instructors in that room. All right, let's see. Now, Pearson, please make sure that you get your access code, because I see that a lot of you will have your temporary access expire on the 19th. But 19th is a holiday. Wait, yeah, we do have a Monday off, right? So make sure that now the only thing is, if you lose your temporary access, if I don't export the student score, then you lose your data. I mean, if you try the first homework, then you're gonna have to do it again. All right. Now first office hours visit. If you want to stop by, that's fine. But if you can ever schedule an appointment from Monday to Thursday in the morning, from 9:30 to 11:30, that will be very much appreciated. But if you want to wait until your first quiz, which is totally fine, right? Because I think that the quiz has to be done somewhere early February. All right. Now 5.2. We do have some application of trig functions that we have to get you guys attempt them. Not to mention that after such a long time, I finally get to let you guys try those evaluation of trig functions using a good calculator. Now the first thing I want to share with you is in the textbook. So let's take a look at this example number 9. So I guess that I could just zoom in a little bit more. So it's not that important for you to read through, the problem and, maybe just the instruction here, because that should be straightforward enough, right? So what you're looking at is a building with unknown height. Some person want to estimate how tall the building is. What this guy did was to walk right from the foot of the building all the way to some point, right, which is 300 feet away from the foot of the building, and then look up and find a way to measure this viewing angle, right, or angle of elevation. So I'm sure you can see with the horizontal distance from the foot to where the person's standing, and also the vertical height, and some imaginary line, right, connecting that person to the top of the building, you have a right triangle. Since this is a direct measurement, right, so the adjacent side of the angle 22. What you're looking for is the opposite. If you recall, one of the Kahoot question says that, hey, one of those which of those trig functions contains only opposite and adjacent? It's gonna be tangent, right? Or maybe cotangent, but I guess that we're more used to the tangent, right? So that's what you use, right? So you just recall the definition of a tangent of angle 22. And it's going to be the opposite of 22, which is the unknown height of the building, right? Divided by the adjacent side, which is 200 feet. And it turns out that even though that this is not a special angle, but you can definitely figure it out with a sensitive calculator. I want everyone, if you have a sensitive calculator with you, give it a try, right? Find the function button on your calculator that says tangent. If you don't have it, that's okay. Maybe just go to Desmos. Desmos has a sensitive calculator. You can play with it. I'll show you in a second how to do that. So if you have a physical calculator, give it a try, right? The syntax might be different, on some of the calculators. Some people have to type in 22, then put in the 10, right? But for maybe the Casio calculator, you put in a 10, then 22, or the TI sensitive calculator. Anyway, type it in and tell me roughly how much you get for tangent 22 degree. 0.008. Okay. That's 10 to the power. Okay, so TI. Yeah. What do you guys get? Okay. 0.44. What about here? All right. Some people get 0.4. Some people get 0.08. Right. So nice. Are you taking some other classes using this calculator? No. You can switch it. Okay. And what about you guys? Chemistry? Yeah. Okay. Now, I read that if you're getting 0.008, that's probably in reading. Right. So now you have to, well, this is good because now this is pretty realistic, right? So in a test, how would you know that you're in radian mode? But you thought that you type in a degree, right? So next, I think that is a way for you to change it. You can play with it, right? I got 0.4. 0.4, that's the degree, right? So tangent 22 degree is about 0.4 something. Now, even though I might not know how to change the mode from degree to radian or vice versa on your particular calculator, what you have to do is either look at the manual or Google it. But what I do want to share with you is on Desmos. You know what? Let me make sure I'm sharing the correct screen. Look, on Desmos, you have these two modes, right? So now you know exactly what RAD stands for. So let's say like a TI, they're notorious with, you got it? Yeah. So they're notorious for not making everything intuitive, right? You have to go into the manual and figure out it, right? So what you have to do on a calculator before you try any trig functions, type in sine 30 degree. Do you guys happen to know how much sine 30 degrees is equal to? You don't have to. I'm just saying that, maybe you should remember from one of the previous lesson. 30 degree. So that's the 30, 60 degree, right, triangle. And I said, here's what I remember, the dimension of three sides. The opposite of 30 degree is always 1/2 of the hypotenuse. So I go ahead and label 1 and then 2. So then I'm left with, this missing side, which is coming from the, Pythagorean theorem, right? I'm going to take the square of the hypotenuse minus square of this, shorter side. And I'm getting a radical 3. So now what do you think? How much is sine 30? Opposite over hypotenuse. So 1/2, right? Or 0.5. So now if you type in enter on your calculator without knowing what it's going to be in radian degree mode, if you don't get 0.5, that means you're in a wrong mode. Right? Now check this out. Radian. Now the reason why you have to try that is if you're ending using it somewhere along the way, there's almost no way for you to figure out right away if you are in a real mode. Right? Now for those who are going to calculus in the future, maybe probably taking physics at the same time. It happens all the time that my students come from calculus to my period, and their calculus screwed up. Because the calculus class asked them to do radians, and they come to my class, they're doing the projectile motion thing, the basketball, right? The angle is going to be in degrees, right? So make sure that if you have a physical calculator, check if you can switch back and forth between the radian and the degree mode. All right, so now we type in tangent. So we need to be in degree, right? 22 to about 0.4. Okay. Now, let me go back to, yep. Oh, okay. I don't know if you guys realize that I'm having some technical issues today. I'm not able to use the screen here for some reason. So that's why I have to go back and forth to switch the screens. Anyway, now back to no, not this. Here. So now what happens is you have 10 to 22, which is given by a calculator, right? Just like 0.4 something. You're looking for the unknown height, which is A. Starting for the A, right? Multiplying both sides, right, with 300, you're getting about 121 feet. It doesn't make sense, right? 10 and 22 is about 0.4 times 300, you're about 120. All right, so it does make sense. All right, so now let's go ahead and try another problem, almost the same. And this time, it might be actually kind of relevant to, something that you kind of do, during the break. So if you go camping, there's a lake out there, right? You want to know how wide it is, right? So I don't know if people go kayaking, in a lake. I mean, they could, right? So what if the lake looks, not crazy, but it's a couple miles, right? I mean, it could be pretty exhausting, right? Or if you know how fast you pedal, then maybe just have an idea how wide it is. Now they provide you a pretty neat way to estimate, the width of the lake, just like the height of the building, right? Let's say you're standing here, you're looking straight across the lake, and you find a reference point. Could be a tree, right? Could be like a big piece of rock. So now what you do is you look straight ahead, and you turn 90 degrees, and you walk. Of course, you avoid the water, right? Walk. And of course, make sure that you keep track of the distance you walk, right? So this guy probably walked, 750 yards. Now, when this guy's standing at this location, right, and he's gonna see the same reference, but at an angle. So if you can measure that angle, that view angle, together with the walking distance, you can find out the width of the lake, right? And again, this is a right triangle, and that's why you want to turn 90 degrees before you start walking. And now, why don't you guys give it a try? Help me to find out how much the width of the lake is. The distance here, AC, is 750. That angle is 24 degrees. Find out the A. You get it? Guys, if you have an answer, even if it's in a calculator, let me know. Good. Mhm. All right. Oh yeah. Anaya asked me, what if you guys get a question like that in the test, right? If you're only able to use the full function calculator. For that part, I'm not quite sure. I mean, we could have section A with all the easy questions that you either use mental math or maybe the full function calculator, right? For the first 30 minutes. And after that, I collect the paper, and you get to work on the second, session where you're allowed to use the pencil calculator, right? I don't know how that's, how realistic that is, right? You only have 50 minutes, 55, right? I don't want to go back and forth, and you have to bring two calculators, right? If you want. Um, anyway, we'll see. Right? The first test, will set the tone for the whole semester. Now, but for this one, let me write down the work for you in case you want to refer to it. So we're looking at tangent 24-degree, right? So that's the opposite, which is the width of the lake, right? Divided by the walking distance, which is 750. All right, so you'll work out A, which is 750 times tangent 24-degree. And, quite a few students already work it out on a calculator. It's about 334 yard. Okay, no big deal. All right. Now, just for fun, let's try it in reality. See, how accurate it could be. Okay. But once you see how that works out with modern technology, then you realize that it's probably no point learning this old-fashioned trick anymore, right? Because your phone can actually do it, without you doing this kind of walking and stuff. So on iPhone, I know there are two things that are pretty handy. First one is the compass. You know what compass is, right? So the old-fashioned one, you get to draw a circle with, right, or measure angles. But this digital one, you can easily measure angles as long as it's in a horizontal plane, right? So you turn, you see how much angles you're looking at. Another thing which is even more powerful is what they call measure. Right? It's a built-in app. Uh, so the leveler, you can measure the angle in a vertical plane. Right? Now for the measure, what it did is, it used what they call AR, right? Not VR. VR is a virtual, reality, right? AR is augmented identity, not identity. Augmented realities, right? So like, I think last time I saw, a map they're using AR is IKEA's app. So, if you like this couch, right, you can have the, IKEA app and choose that couch and just use a camera, of a phone and project, couch in your living room, just see how it looks like, right? That's called augmented, right? Augmented is like enhancing the reality. Anyway, so now what the measure app does is you get to pick 2 points in the space and they will actually measure the distance. Pretty accurate. I think that's pretty powerful, if you go shop for, something, or maybe your parents go around and, go into the open houses, right? If you're looking at property, you can measure, like the square feet or whatever, right? But now let's imagine uh, the size of the room is like a lake, right? Like a square lake. So I'm gonna measure the width of the lake, right? Which could be just the width of that blue wall, right? But instead of directly measuring it, right? I could use that, use the measure that to do it. Let's pretend that I couldn't really, do the direct measurement. So what I'll do is I'll start from that corner, right? That's like, the point C. I'm looking straight ahead at a point right across the lake, right? And I find the reference. So now what I do is I turn 90 degrees and then walk straight, right? And I count the steps or maybe find a way to, measure the walking distance, right? I'm going to get AC. So if I can measure the walking distance, right? Then with the view angle, I can calculate the, the width, right? The same way. Well, of course, there are decimals out there, right? It's not going to be seriously walking and try to do the measuring. So then I'm going to, cheat a little bit using the measure to get the distance. Right, so now iPhone's telling me from that corner of the feeding all the way there, that let's pretend that I was walking that far, right? The distance is about 5.8 meters. Right? Can anyone write it down? 5.8 meters. All right, so that's the walking distance. So now remember what I have to do. I finished walking, right? So now I'm gonna look straight ahead, the same reference, right? To see what will be the viewing angle, right? Now I'm measuring a horizontal change in the angle. So I have to use compass. Right. So right now I'm looking at, well, you couldn't see it. Right now I'm looking, this is actually the due south direction. I'm looking at 194 degrees. So as I gradually turn until I see that this pointer lines up perfectly with that reference, right? The far back corner. I'm looking at 248 degrees. So guys, help me to find out what's the difference between 248 and 197, 196. Yeah, 248, 196. 52 degrees, right? Go ahead and put it in. Now, the angle is 52 degrees, right? Tangent 52. The walking distance, if you should remember, 5.8 meters. Find how much you get for the width. 7.4 meters, right? Well, that's about right. So now I'm gonna measure this. Well, it's quite off, 6.7 meters. Well, I don't know what to say. Hey, close enough, right? Well, you better not say that all the time on the physics lab report, because students always go with close enough, right? They don't want to do anything about the error analysis. But hey, the reality is, if the kind of measurement is quite off, but think about how much is off. The actual distance of the measure, if I want to trust the app, let's say 6.8. It was 7.4, right? Some off like 60 centimeters, like half a meter. Half a meter out of what? Out of 7 meters. So how do you expect? How much do you expect as the width of the lake? It should be, this could couple hundred yards, right? If you all find a yard, would that be a big problem? No, right? Because remember that your goal is to roughly estimate how much it is, right? Not trying to be super accurate. So I'll say that this works because it requires minimal, fancy technology, right? But you do need, some knowledge in Trig, right? But nowadays it seems pointless because you might have much more reliable technology to use, right? Why bother? Anyway, well, you know what? Things went smoother than I thought because I thought I have a hard time with technology. You'll have to switch back and forth. So you know what? Let me get started just with some basic idea of 5.3. Well, since today I'm we're not gonna do anything about the trig tomorrow, and you get a Monday off. So in the next couple of days, if you could preview the section 5.3, that will be very helpful. Okay. Now guys, take a look at the title here. 5.3 going to tell us something about the trig functions of any angle. Does it scare you when I say any angle? Literally anything. Any number you can think of. Right? Even imaginary. You guys know what imaginary number is? Right? Yeah, you can even put in imaginary numbers in. But I think it sounds pretty scary. Right? Exactly. Yeah. Well, Google Euler identity. You know what it is. Euler formula. Yeah. That famous mathematician. Euler. EULER. Anyway, so any angle means any number, right? But right now, let's focus on real number. So there are infinite many choices, right, for a real number. So that means if you put any number that you can think of into a sine, cosine, tangent, it's fine. But some of the angles, might get you some crazy, things or math error. But most likely, it'll be fine. Nope. So let me show you the textbook. All right. Now, let's say before we get to these things seriously next week. So over the weekend, if you do want to spend some time previewing it, make sure that you take the figure 5.32 for Thursday. But let me explain, what you're trying to get around this figure. So you probably recall back in 5.1, we say the standard way to draw an angle is to put it in a coordinate system, right? And let the vertex of the triangle, the angle, exactly at the origin. Let the initial side going along in a positive x direction. So now, in order to get different angles, you have to turn the terminal side, right? Either in a clockwise direction, you're getting positive angles, or if you turn the other way around, you get negative angles. And you can always, locate where the terminal side is and use it as a way to refer to whether the angle is in the first, second, or third quadrant, right? But now we want to be more specific. Yes.
Sorry, the square that indicates the range is outside, and then for the inside.
So it's actually not going to make a big difference. I think that it's probably just the author's choice. Yeah, but that if this is the right angle, the one inside has to be right. Now, the question is, can we precisely locate where the terminal side is? Because that where the terminal side is located, determines how much the angle is, right? So how do we calculate the angle if we have the location of terminal side? They say, hey, just pick a point on the terminal side. Let's say point P. And that point could be anywhere along this terminal side. So let's say if you want an angle that's in the second quadrant. And what you do is, you can imagine that you're going to have that point P somewhere in the second quadrant. The terminal side is going to go through it, right? And now, do you see that the terminal side now depends on the x, y coordinates of the point P? Am I right if I say, since there are infinite many choices for the location of the P, in this two-dimensional coordinate plane. There will be infinitely corresponding angles. Right? And now think about what could be the numbers you pick for x and y when it comes to defining where the p is. They are all real numbers, right? And therefore, the corresponding angle can take all real numbers. So what they have been doing is they are mapping an angle, which is a geometric but somewhat abstract concept, to the location of P, which is easier to find, right? And I'm sure that you guys are very familiar with, right? How to locate a point P. So you're building a map between an angle and the location of P. And that's what a function does. Because so far, we've said a lot about, hey, we have trig functions, right? We have sine and cosine tangent. But I haven't heard anything asking me, hey, Dr. Wang, you said trig function. Where's the x? If it's a function, right, where's the independent variable? Right? Is theta an independent variable? I mean, it will be. And we're getting there. Right? And I'm not sure, if you remember back in 2.1 in college algebra, introduced you the idea of a function, right? So if you do remember what a function really represents, it represents a relation, right? A very special kind of relation. So what it does is you probably don't know what's going on with this particular function, like when it comes to the algebra. But all you care is if you feed something to the function, it's gonna spit out, a output, right? Mapping an input to the output. So now what we're trying to do here is we're mapping an angle to the location of P. If you feed an angle to a trig function, it will tell you where the P is. You know what? It works the other way around. Right? And that's why we are along the way to build the concept of trig functions. Because after all, it's a function. And that's why, there are a lot of functions that takes all real number in its domain. Right? You guys remember that? There are so many functions that are like that. And trig functions are one of them. But not all 6. Sine and cosine functions later on will be the kind of a nice functions that takes all real numbers in the domain. Yes, Russell?
You said trig functions find P, but when you've been using them, they don't use to find the distance between points.
Well, so we're not there yet, but later on, let's say the easiest way for you to see that why you're able to find, either the location of P or vice versa, is to think about what if the angle is limited to be less than 90 degrees. So let's say if I want the P to be 1 unit away from the origin. Okay. The angle here will be let's say 60 degrees. Or you know what? Make the distance from the P to origin 2 units. Right? Oh, I do have the special triangle here. Let me redraw it. This is the origin. That's 60 degrees. Right? So that's what the P is. So I want the distance between point O and the P is 2 units. The angle is 60. Do you guys think you can find out exactly where the P is when it comes to its x and y coordinates? The opposite is y, right? The horizontal coordinate is the adjacent side. Now, how much is y? Take a guess.
1.
It's the opposite of 30. That's 1, right? So this is my bad. I didn't draw it, the right way. So it probably doesn't look like a 30, 60 spiral triangle, right? But if this is 60, that's 30. The opposite of 30 is actually half of that quantity. So x is 1 and y is radical 3. So now, of course, I'm trying to use a special angle, right? So I don't have to go through the, the detailed match. But you see that this is like, you tell me how far you want to be away from the O, and looking at what direction. You can pinpoint where you're located when it comes to x and y, right? Isn't that just mapping an angle to a particular location, right? Yes.
Only apply the time. The y